Okay, everybody, welcome to the Math 3 meeting here for May 14th as we continue through Unit 9 statistics and move to the last ones, whether you're watching live here today or watching the recording on YouTube or any other methods. Thanks for being here. We're in Unit 9, so we are at the end of the Math 3 curriculum, and I'm going to recap a couple things for everybody before we start and go through our new stuff. So let me go to our class page. If you go to our class page, you'll see everything from the phases that we've done, and you can see more announcements by clicking on announcements all the way back through all of our weeks that we've been working on remote learning. Please remember to click on modules. So let's talk about everything we've done in the Math 3 course. Unit 1, early in the semester, was on quadrilaterals. So we learned about quadrilaterals and all the geometric parts of that. Number 2, Unit 2 was on circles. Unit 3 was trigonometry, so our sine, cosine, tangent, and then the unit circle. Unit 4 was absolute value, so we talked about absolute value equations, absolute value inequalities, and then graphs as well. Unit 5 was functions and graphing, so we talked about all the different functions, like a linear function, a quadratic function, a cubic function, an absolute value function, all those different types of functions, and their graphs as well. Unit 6 was polynomials. So we talked about adding, subtracting, multiplying, and dividing polynomials, and then how to solve those. The multiplying, sometimes we use the box method. The dividing, we use synthetic division. Adding and subtracting, we had to combine like terms. Unit 7 was rational expressions, where we dealt with fractions, and we talked about factoring those fractions to get them to cancel out. We did adding, subtracting, then we did multiplying and dividing, where if you were dividing, you had to flip the second fraction. We worked on solving equations, where you had to solve for x. And then we worked on the work problems. Remember, if one person can do a job in so many hours and the other person can do the job in so many hours, how long would it take them to do the job together? All right. So that brought us to Unit 8, which was logarithms and exponential functions. And we started with the exponent rules. We went through applications of exponents and logs, like where you could use it with money. We talked about the properties, adding, subtracting, and using the power rule. Talked about some exponential equations and then graphing those. And then we dealt with what the ln and e function was on your calculator. And so then we moved to our last unit, Unit 9, statistics, and we began by analyzing data. So analyzing data was going through and getting some data and doing stat calc, one variable stats, and looking at the mean, looking at the median, looking at the range, and then actually just looking at the numbers ourselves and seeing what the mode was, and then also going through the standard deviation and the variance. And then we had a homework page on that and an IXL from yesterday. So if you'll make sure, when we started the phases, we actually began right after March 13th. So we began with Unit 6. So you had finished 5 units when we left school and began the remote learning. So Phase 1 actually began with Unit 6, and Phase 2 was basically Unit 7. Phase 3 has been all of Unit 8 and this beginning part that we're continuing now with Unit 9. So if you'll make sure you go back, and I just wanted to recap all that because some of you have gotten behind. Some of you have completed the stuff on, some of you have completed the stuff when we're talking here on Zoom, but you haven't submitted it. So I want to give you an opportunity to look through all that and kind of recap what we've done this semester. So you guys have done a lot, and you should be well prepared for the next math class that you come to. And I do appreciate that. So I think you've still gotten a lot out of this. Hopefully, still got a lot of learning, even in a tough situation. So let's go to, I'm going to share with you my page today. If you'll turn with me to 9.2 sampling. So this is section 2 of, this is section 2 of our 9th unit. If you notice, tomorrow is the last day of our unit. Tomorrow is the last day of our unit, and that is going to be the homework part of 9.2. And then on the 18th, which is Monday, that's when you are able to pick up the Phase 4 packet. And Phase 4 is basically going to be a review of the important things and things that they could ask you if there was an exam. So the key concepts from Math 3. And Phase 4 will only last May 19th, 20th, 21st, and 22nd. So Tuesday, Wednesday, Thursday, and Friday of next week. And we will be done. And your semester will be over. And you'll be able to enjoy a little break from schoolwork and all this, and hopefully come back normal in the fall. So if you will, make sure you pick up that. You do not need to turn in a Phase 3 packet for me as long as you are submitting everything on Canvas. If for some reason you've been unable to submit things on Canvas and you want to turn in the paper copy, then you can. But the easiest way would be to submit it on Canvas and let me go through and check you off that way. All right, so let's go 9.2 sampling. Does anybody have any questions before we begin on this? No questions in the chat? All right, so let's move to 9.2 sampling. So the goal of this section is to identify and apply methods of data collection for the purpose of statistical analysis. So for an event to be, and the goal here is for an event to be random, is what we're talking about here. For an event to be random, there is no predetermined pattern or bias toward any particular outcome. So for something to be random, then it just when we say something happens at random, that means there's no predetermined pattern and there's no bias towards one thing or the other. So let's look at example 1. A class of 25 students wants to choose 3 students at random to bring food for a class party. Any set of 3 students would have an equal chance of being chosen. Which of the following strategies will result in a fair decision? Are these scenarios random? If not, explain. So in A, would it be fair if the students line up alphabetically and each one in succession flips a coin? The first 3 students to flip heads get to bring the food. Is that fair? And then why? So I want somebody to try to answer that for us. Is that fair and why? Anybody in the chat? Yeah, well, why would it? Okay, well, think about it. If I line the whole class up alphabetically, all right? So let's say I line the entire class up alphabetically, and I say if I line the entire class up alphabetically and I say, all right, last name of A, you have to flip a coin. If you get heads, you bring food. Then the next person, if you get heads, you bring food. And then the next person, but only 3 bring food. What will happen more than likely? What's going to happen more than likely? Yeah, more than likely, people at the top of the alphabet, at the beginning of the alphabet, are going to be the ones chosen. So this is not fair. So we're going to say this is not fair. And what happens is people at the beginning of the alphabet are more likely to be chosen. Now, if you were thinking that it was fair, well, each person that gets a chance is going to have a 50% chance of being chosen. It's going to be 50-50. So that is fair. But the problem is every person's not going to get a chance. So like by the time I get to the last name of F or G, I may have already gotten my 3 students to bring food. So all the students towards the end of the alphabet may never be asked to bring food, right? So the students at the beginning of the alphabet, if they get chosen, they're going to have a 50-50 chance of either bringing food or not. But I'm not going to get to these students towards the end of the alphabet. So it's unfair because everybody's not having that 50-50 chance, okay? So let's go to B. Each student draws a card from a well-shuffled deck of 52 cards. The teacher shuffles a second deck of cards, spreads them out, and draws cards one by one until he matches the cards of 3 students. Is that fair or not? So think about this second one. Is that fair or not? So like I give you a deck of cards and I say everybody pick a card. And so everybody's got their own card. Then I take out a second deck of cards and I draw one out and I see if you get a card or not. So yes, this is fair. So this is fair and it is random. It is fair because every student has a card and so every student has a card and has an equal chance of being chosen. So in this case, every student will end up getting a card. And I have a second deck of cards, so I have all the cards as well. And so everybody's going to get an equal chance of being selected. So that's what's going to help make this one fair and make this one random for us. So fair and random is what we're looking for, right? When we're talking about this, we're looking for something to be fair. We're looking for something to be random. So that's our goal in this. Our goal is to make something fair and to make something random. All right. So let's go to our next part, example 2. A random number table contains randomly generated digits from 0 to 9. So here's what you need to see here. Basically, all these digits that go across are just randomly created. That's called a random number table. You just see random numbers placed out here from 0 to 9. You can use these numbers to model randomness for sampling purposes. A coach wants to select 3 of her 15 basketball players give me 1 second. A coach needs to select 3 of her 15 basketball players at random to lead warm-ups before practice each week. The coach assigns each player a number 01 to 15. How can the coach use the random number table to fairly choose the 3 players? So what you need to do is you need to start at the beginning. Okay? You need to go 2 digits at a time. And you need to select the first 3 players that you come to. So let's do that, okay? Let me show you how that's done. So if we start in the top left, the first 2 digits are 87. We don't have anybody numbered 87. All our players are numbered 01 to 15. So they're 01, 02, 03, 04, 05, 06, 07, 08, 09, 10, 11, 12, 13, 14, 15. So the next number is 49. We don't have anybody there. The next number you go across is 43, the next 2 digits. We don't have anybody there. The next one is 97. We don't have anybody numbered 97. The next one is 07. We do have somebody numbered 07, so that's our first player to be selected. The next number is 20. We don't have anybody numbered 20. Okay. The next 2 is 52. We don't have anybody 52. The next 2 is 59. We don't have anybody 59. The next 2 is 57. We don't have anybody numbered 57. The next 2 is 04. We do have a player numbered 04, so that's our second selection. The next 2 is 48. Nobody's numbered 48. Next 2 is 36. Nobody's numbered 36. The next 2 is 12. We do have a player numbered 12. So if you notice, by going 2 digits at a time, we have selected player number 7, player number 4, and player number 12. Does anybody have a question about how I did that? So I started in the top left and I went 2 digits at a time and I'm basically ignoring any digits that aren't from 01 to 15, right? So I'm ignoring anybody that's outside of that range, and I'm selecting 3 of the 15 players. If you have a question about that, let me know. If we're good, I'm going to move forward, okay? All right, so simulations and probability models is the bottom here. And what this says is you can use and this is called simulation. So you can use a simulation to assign probabilities to outcomes of a chance process. Example 3 says, suppose that you are playing a board game for which you must roll a 6 on a number cube. Okay, suppose you are playing a board game for which you must roll a 6 on a number cube, which would be like a die, before you are able to move your game piece from the start. Describe a simulation you can use to predict the number of times you would expect to have to roll the number cube before you can move from the start. So what should happen is, so you can use a random number generator. It's what it's called. And we have that on our calculator. I'm going to show you what that is. You can use a random number generator. And if you must roll a 6 to be able to move, then that means if you roll a 1, 2, 3, 4, or 5, then you can't move. Only time you can move to the next spot is if you roll a 6, okay? So we're going to use a random number generator. So we're going to say random integer, int, and we're going to do 1, 6, okay? So I'm going to take you to what this looks like on the calculator. Random integer 1, 6. And what this will do is it'll randomly select a number from 1 to 6. And if it's 1, 2, 3, 4, or 5, then what that means is we don't get to move. And if it's a 6, then that means we do get to move. This is called a simulation because we're not actually using the number cube or the die. We're using the calculator to simulate the process. Kind of like we're using a random number table to simulate the process of picking 3 players. So let me show you my calculator here. On the calculator, you go to math and you go over to probability. And it is number 5. It says random integer, random int. That stands for random integer. And you click on that, and you would say my lower is 1, that's the lowest number I want, and my upper is 6, and I can paste it. And it's going to pick a random number from 1 to 6. Now, I can hit enter again, and it'll pick another random number from 1 to 6. See how I keep hitting enter? It keeps picking more random numbers. So if a 6 is selected like that, then that means that I can move from the start. If another number is selected, like the number 2, or the number 1, or the number 5, or 3, or 4, then that means I'm not able to move from the start. So what's the probability that I'll get to move from the start? What's the chance that I'll get to move from the start each time? What's my probability? Yes, somebody sent me the correct answer. It's 1/6. You got a 1/6 chance, right? So there is a 1/6 probability of moving from the start, right? Because think about it. There are 6 possible sides on a die, or 6 possible numbers we're talking about here. And 5 of those have us standing still. And the 6th number is the one that has us being able to move. So there is a 1/6 chance, 1 out of 6, that we'll be able to move from the start on this. Okay, so that takes care of page number 1. So let's move to page 2. And now we're going to talk about different sampling methods. So these are different sampling methods and different types of studies. So I'm going to read these for you here. All of this is included in AP Statistics. It's actually in Unit 3 of AP Statistics, which is called Collecting Data. So this is a good thing to know that you will see again if you take the class. So sampling methods. These are always, so if you want to sample people, like if you want to take a survey or you want to know something about a lot of people, then what you want to do is you want to take a sample. And when you take a sample, then that will tell you about the entire population, right? If you take a good sample. Well, these are ways of taking a sample. The first one is a convenient sample. In a convenient sample, you select any members of the population who are conveniently and readily available. So that means like you would pick your friends or somebody right beside you. Okay, that would be a convenient sample. If you pick like the easiest people to do. Now, a convenient sample is obviously not the best, but it is the easiest type of sample to do. Okay, a voluntary response sample. I'll give you an example that's something that just happened. The graduation poll is a voluntary response sample. They sent that out to all seniors across the county, to give them the option of what type of graduation they felt like they would like. But that was voluntary response. Only members of the population who volunteer for the sample are in it. So that means like they didn't have to respond. They didn't have to submit the survey. There was nothing requiring them to. It was just voluntary response. So a lot of times in voluntary response, you get the people who feel very strongly about one side or the other, and you miss the people in the middle because they don't really care, so they don't send it back. A phone poll would be voluntary response, where they say, call into this number if you feel this way. Or voluntary response could be where you go to a website and there's a poll on there, and if you want to, you could answer it, but you don't have to, right? It's voluntary response. The third one is a systematic sample. You order the population and then select it from regular intervals. So, for instance, we could be standing at the front door of the school and saying that we're going to sample every 5th person that walks in. Or we could be standing at the cafeteria and say we're going to sample every 10th person in line. Or maybe we order the students in alphabetical order and we say we're going to sample every 3rd person in alphabetical order. So it's a system. So a system means every so many people are going to be in your sample. And then lastly is just a random sample. And that means all members of the population are equally likely to be chosen. And you'll see this called an SRS, which stands for simple random sample. So if in a simple random sample, everybody's going to have that equal chance. So if we have a class, it's just like putting everybody's name in a hat, shaking up the hat, and drawing a name out. Like everybody was in there, everybody had an equal chance of being selected. Okay, let's go to the types of studies. There's 3 types of studies here. The first type of study that I'll read is just a survey. It's the most basic one. You just take a sample and you ask them questions. So it's just, if you want to gather information, then you want to use a survey. Okay. Next is an observational study. Members are observed or measured in such a way that they're not affected by the study. So if you're doing an observational study, you watch people basically doing what they already do. So maybe you want to know if more people use the drive-through than carry-out right now. If more people use the drive-through than use the carry-out at a restaurant. So you could go to that restaurant and observe how many cars go through the drive-through and how many cars actually park and use carry-out and pick up their food. And that's an observational study because you're not telling the cars to go through the drive-through. You're not telling the people to go to the carry-out. You're just observing what they're already doing. So that makes it an observational study on this. Okay, and then the last type of study is a controlled experiment. This is the most intense, right? So you are working here. You're doing this as the experimenter. The sample is divided into 2 groups. So you take your sample, if it's all your students, you divide them into 2 groups. There is a treatment that is imposed on one group, but not on the control group. And then we want to see the effect of the treatment. So an example of that is if we're testing out a new drug, or let's say, if we're testing out a new drug to help with headaches, let's say, then what we would do is we would take our sample, we would randomly split it in half. So people would randomly get picked to one group or the other. And then the people in group 1 would get the new headache drug, and the people in group 2 would get the current headache drug, like Tylenol. And then we would be able to compare those 2 groups and see if there's a difference. So are more people, are they getting rid of their headaches quicker with this new drug than Tylenol, or is there really not any difference at all? So we would be able to tell and make some conclusions about that in an experiment. Okay. Bias is very important. So you've probably heard that in your life at some point, if you're biased or not. Bias means that it's a systematic error that's introduced by the sampling method. It means that it favors a certain outcome. Okay, so if you only survey a certain age group or exclude certain people with specific opinions, so if you only pick your friends, to be in your survey, or you want to do a survey about Lincolnton, but you only survey the freshmen and you leave out the sophomores, juniors, and seniors, then you have created bias, right? If you want to do a survey or a sample, you need to get a good representation of the population that you want to reach. If you only pick a certain part of that population, then you have introduced what's called bias. So example 4 says, what type of sampling method is used in each scenario, and is there any bias in the sample? So let's look at A. A service surveys every 25th listing in a local directory. So they go to a phone book and they pick every 25th number that's in that phone book. So what type of sample is that? Look at the 4 sampling methods up above where it says sampling methods, and which one is A? Which one of those 4? Is it a convenient sample? Is it a voluntary response sample? Is it a systematic sample? Or is it a random sample? Giselle says systematic. Anybody else? What do you think? Zach says systematic. It is a systematic sample, so she's right. Good. Secure. So it is a systematic sample, and the reason it is because in systematic you're surveying every so many people. Okay. Now, so it is a systematic sample. How could this be biased? How would this be biased? So who are we missing in this type of sample? So if we go and we survey every 25th number in the phone book, who are we missing? What would make it biased? Looking for some type of response here. What would make it biased? If we survey every 25th member in the phone book, who are we missing in this? Come on, who are we missing? If our goal is just survey, if we're just trying to survey every 25th listing in the phone book, why would that be biased? Why is that not getting the, why is that maybe not representative of the entire population? Who would we be missing in this? Who wouldn't have a chance of being selected? Yes, Giselle, yes. The people who's not necessarily that they don't have a phone, but yes, those people too. But people whose phone number is not listed. That's who we're missing. So people whose phone number is not listed don't even have a chance of being part of our survey. If they're in the local directory, then they at least have a chance of being selected. But the people that aren't in this local directory, people whose phone number is not listed or that don't have a phone, they don't even have a chance of being in our survey. So we're missing those people. Okay, let's go to B. A reporter interviews people on the street in a large city. What type of sampling method is this? So he wants to know about a large city, so he just interviews people down on the street. Think about like a large city like Charlotte. He just goes down to Tryon Street and interviews people. That is a convenient sample, okay? Because he's going to one street and just interviewing people about what they think in this large city. He should be going all around the city to different places and going through and doing that. Now, how can this be biased? Think about how the people that are on the street change. What might give you different people in your sample, like on the street? What might be important about how he interviews them? Yeah, well, he just wants to know about that large city. So if they don't live in the city, then he doesn't want them to be in our they're not in our population anyway. So we just want to know about this city. But yeah, if they don't live close to that street, the other thing that can make this biased is when he does this, right? So the time of day / location / day can affect who is on the street, right? So like if we do this survey at 9 a.m. or 8 a.m., we may get people going to work. If we do this survey at 9 p.m., we may get people that have gone out to eat or people late at night. If we do this survey in the middle of the day, we're not going to get the people at work, so we may get a completely different set of people. So it's going to be important, and it can be biased based on what time of day he does it, where he decides to do this, and does he do it at a location where there's a lot of businesses, or does he do it at a location where it's just like the neighborhoods, you know? So that's why when you're doing a survey like this, they typically will do it at different times of the day to get different people, and they'll typically do it at different locations. So these are all ways that a survey can be biased, and these are all ways that you can actually help make it not biased by doing those. So C, a radio station allows people to call in to give their answers to a survey. What type of sample is this? Yes, that is a voluntary response sample. So this last one is a voluntary response sample. And again, we already talked about this, but voluntary response samples are biased in that people who call in, people who call in usually feel very strongly one way or another. Yeah, like if they ask you to respond to a survey about like the cafeteria food and you're okay with the cafeteria food, then a lot of times people don't respond to it. But if you really hate it or think it's terrible, then you'll respond. Or if you just absolutely love it and it's your favorite thing ever, then you'll respond. So typically in a voluntary response, you get people that have really strong opinions or this strong connection to the survey. But if they're kind of in the but the majority of people are in the middle, you know, they're people that maybe don't lean strongly one way or the other, and we miss all those people in a voluntary response because they're not going to take the time to respond if they don't have to. And that's the issue with the voluntary response sample. All right, so let's go to the bottom of this. It says survey questions. To create an unbiased survey question, you want to avoid this. You want to be just straightforward and ask the question, right? That's to create an unbiased survey question to somebody. You don't want to say, you know, online learning has been very hard and all these students aren't doing anything. Do you think we should do it again? That would be biased. Or you don't want to say, this online learning is great. You get to do a class in your pajamas. Do you think we should do this? You have to say, how do you feel about online learning? I mean, it has to be a straightforward question, right? So you want to avoid combining two or more issues, using double negatives, overlapping answer choices, words that can cause a strong reaction, and leading the subject to an answer. So a lot of times, people and news outlets will do this. They'll create surveys and they'll ask questions that kind of lead you to pick one answer, over the other, and then they can kind of get the results that they want. So example 5, are the following questions biased? And if they are, explain why. So let's look at the first question. Do you think that the food and beverages being served in the cafeteria taste good? So why would this one be biased? So it is biased. Why is it biased? It's one of our issues up here. Look up at one of the issues that it said to avoid. What have they put in here? Here's my question to you. What if you think the food tastes good, but the drinks don't? And what if you think the drinks taste good, but the food doesn't? How do you answer that question? You can't, right? So they're combining two different things into one question. So really, to not be biased, they should say, do you think that the food being served in the cafeteria tastes good? Then they should ask a separate question, do you think the beverages being served in the cafeteria taste good? That way you can get a true answer about each individual issue instead of trying to make an answer about both of them together. Okay, B, don't you agree that the school days should be shorter? This is biased. Why? So we say, don't you agree that the school days should be shorter? So that's biased because why? Absolutely. It's leading you to say, yes, there need to be shorter because it's actually telling you their opinion. So it's leading you to an answer. So the person asking you the question is actually saying that they believe the school day should be shorter, right? And they're saying, don't you agree? And a lot of times we don't want to, if we know somebody's opinion, we don't want to, go against them. So it's easier for us to just say, yeah, of course, rather than the question could say, how do you feel about the current length of the school day? Or it could say, do you think the school day should be the same, longer, or shorter? It's got to be a straightforward question. All right, C, do you prefer watching exciting movies or reading dull books? So this is biased because why? And I would say it's got to do with this to deal with this. So it's words that cause a strong reaction, right? So it should just say, if you could mark out these two words and it says, do you prefer watching movies or reading books? Then you could pick one, right? But because it says, do you prefer watching exciting movies or reading dull books? Then it's going to lead people to pick what? What are people most likely going to pick in this case? In this question, they're going to see people most likely pick movies because they're saying the movies are exciting and the books are dull. But if they would have said, do you prefer watching just a regular movie or reading a great book? Then people may choose books more. So they are leading it in with words that cause a strong reaction. So it's biased based on the wording of the question creates a strong reaction. So if you look, the ways of making a question biased, we found 3 of those. So in this first one, they combined 2 or more issues together, the food and the beverages. In the second one, they said, don't you agree school days should be shorter? They led you to an answer. In the third one, they said, do you prefer watching exciting movies or reading dull books? They used words that cause a strong reaction. So it was the wording of the question. So that's how things can be biased. So bias is very important. Now, it's almost impossible to ever have a survey, observational study, experiment, or something without some sort of bias. But the goal is to limit the bias as much as possible. So our goal is to get rid of as much bias as you possibly can, right? And to make it as fair a question as possible. That's always the goal in a good survey or observational study or experiment, is to get as fair a question as possible. Cole wanted to see the bottom of page 1. It's here right now. But so today we've been able to go through 9.2 sampling, and you should be able to see these different sampling methods. So the sampling methods that I want you to really be able to see is a convenient sample, a voluntary response sample, a systematic sample, and a random sample. I want you to know the difference in those 4. And I also want you to know the difference between a survey, an observational study, and an experiment. And I also want you to be able to tell how something could be biased. And there could be multiple answers to some of these, right? So we're writing it out. There could be multiple answers. So again, there's not much math involved in this section in 9.2 because we're really collecting data and analyzing the data, kind of like we did in section 1. So there's little math involved here, but it's more of describing and making sure you understand what's going on, okay? So we'll come back tomorrow with the homework. We'll actually do like a Quizlet or Kahoot game towards the beginning. So if you'll make sure you log on right on time so that you can be a part of that game, we'll do that, and then we'll talk about some homework, and we'll end the week tomorrow here going through the 9.2 sampling homework. So if there's not any questions, I am going